Hey, hello, and welcome to the show. It's me, John Park, and you are here just in time for JP's product pick of the week. Actually, I'm a couple minutes late, and I apologize for that. I didn't wear this in a couple days, and I forgot to put it on my watch winder, and it was 10 minutes late. And I looked at my phone and said, "Hey, the show has started." So my apologies to you. I need to use my little watch winder thing. So what's going on here today? I've got a cool new product pick for you. And if you want to go and check it out early, go to that QR code right there. Go to that URL because that will take you to the product page. And right there you will find this show being rebroadcast from inside the page. And you can get a discount. It's 50% off today on the mystery product. You don't need a coupon code or anything like that. We'll just price it to sell, and that price will go back up right after the show. So do it while it's hot. And before I go any further, one thing I like to do is have Lady Ada tell us a little bit. Oh gosh, my autofocus is going wacko. Have Lady Ada tell us a little bit about it. Now, this is not one that had a new segment. However, it did have a really good eye on NPI, so I re-edited that into a condensed form. So, Lady Ada, from Eye on NPI, take it away.
The STC CO2 sensor is unbelievably small, only about 3 by 4 by 1.2 millimeters, easily pick and place, low cost, uses thermal conductivity to measure CO2. Pretty good accuracy, plus or minus 100 ppm. It's calibrated in factory. Good for 400 to 5,000 ppm, so basically for indoor usage. It's not designed for like scientific CO2 measurements, but it's excellent if you're like, hey, I want to measure the CO2 levels of my house or my school or my office. What's interesting is CO2 sensing for environment. It's been used by HVAC people for a long time to keep track of, whether there's good air circulation. But basically, in 2020, CO2 became a way of measuring how good air circulation was for the avoidance of COVID transmission, because it seemed to be well correlated. If you had a lot of good fresh air coming in, the risk of transmission was reduced. And so schools and homes and offices started caring a lot about CO2 measurements. And Sincerion happened to be like right there with really good sensors. I definitely notice if CO2 it's high in my room. Well, now I can measure it. Once it gets over 1,000, I'm like, oh, it's a little stuffy. And I'm like, right, let's open a window. But people may not notice it. I've had people take our sensors and do projects, and they're like, whoa, I didn't realize that in my basement where I work, I do electronics, it gets up to like 2,000, 3,000 ppm. And I'm like, yeah, you need to work on your air circulation. It's stuffy and you may not even realize it. The SCCC is much, much, much smaller. It's not going to be the most precise, like it does use a different way of measurement, but it's definitely better than the equivalent CO2, the ECO2 sensors, which basically guess based on gas measurements using like MEMS heaters. So this their technique that they're doing is going to be a lot better. It'll actually get true CO2 measurements. However, it does expect you to have kind of classic air composition. Like it's not going to work in a scientific environment where the composition of the air, with CO2 and nitrogen and oxygen is out of kind of the standard composition that you'd expect for like human environment. One thing that will greatly improve the quality of the readings, the temperature humidity sensor that would be used to basically calibrate against the ambient air temperature humidity. So what you can do is there's 2 pins that have like a peripheral I2C connectivity, and you can connect an SHT 40, 41, 45. I think the 40 is plenty good, and it's very inexpensive. It's like $1 or $2. And it will automatically read the measurements from that sensor because they're both from the same company. It knows the setup for it. And you can still read the temperature humidity through the STCC4. What's nice is that you don't have to like do the thing where you write the temperature humidity to the sensor. The sensor will like read those values when it feels like, oh, I need to recalibrate. So that's kind of nice. But you do have to buy those as a separate component. Fairly low power, in active mode, it's about 4 milliamps, but On average, given that you're only sampling every 10 seconds or so, it's about 500 microamps. Sleep mode is 1 microamp. You can measure, you can power it from 3 to 5 volts, is the VDD at the top there, and ditto for I2C. However, because if you're using the SHT4X as like the peripheral temperature humidity, and those are limited to 3.3, I would just say run the whole thing off of 3.3. You can. As people who've used Sensorion sensors are used to, there is I2C commands that you have to use to put it into mode. They do have an Arduino driver, and they also have I think Python and like embedded C. But also the commands are very simple. It's not like there's some weird binary blob. You run the command, you read the data. I believe there's a CRC or something as well, and you get the results out. So they do document the entire command set. They can also get started very easily with the ready-to-go drivers. But also, I designed a breakout board as well that'll come out with soon. So you can see the draft here. I added SHT41, but maybe I'll go with a 40. And then you can see the sensor at the bottom. They're very small, very compact, pick and placeable sensor. So I think this will be great for wearables or indoor monitoring. You don't have that big chunky SCD30 or the SCD4 that takes up a lot of space. This can fit pretty much any enclosure.
Yes, that, right. That right there. So jumping ahead from that moment in time when Limor was just checking out the chip, she went ahead and did make a whole breakout for it. And it's awesome. That right there is the product pick of the week this week. It is the STCC4 plus SHT41 CO2 temperature and humidity breakout. So this is a Stemma QT, so I2C, and we now have Arduino and CircuitPython Python library driver for it, so it's easy to work with. I'll show you a demo of it in action in a second, but this is really perfect for that indoor CO2 monitoring that lets you know, are you starting to get really sleepy because of a lack of fresh air? Throw open a window, go outside, take a walk. So this helps with measuring room ventilation. It's a high quality, small, low cost CO2 sensor, and it is a true CO2 gas sensor, which uses thermal conductivity to measure the gas. It's tuned for indoor air monitoring. And it does require a weekly self-calibration, so you can just take it out for a few minutes outside into the fresh air and then bring it back inside and you'll be good. It is factory calibrated, but you want to bring it into a known good environment, so about a 400 ppm measurement outdoors is good. The SHT41 that's connected to it is connected directly to it, so it's able to feed the STCC4, the humidity and temperature, to get even better readings. However, you can also just ask for those. So it's not just used to give you a more accurate CO2 reading, but you can also use this just as a general temperature and humidity sensor. And let's get to a couple other product photos there. You can see it from the front and back. The little sort of off-white and metal package there is the CO2 sensor, and then above it is the little humidity and temperature sensor. Let me go to my down shooter and tell you what we're looking at here for a moment. So I've got a Metro, I think this is the RP2350, and then on top of it I have this nice RGB matrix backpack, so we can do some readouts there. Plugged into it over Stemma QT, of course, is my little STCC4 plus SHT41 CO2 and temperature and humidity breakout. And I'm reading those, and then every, I believe it's 20 seconds I have it set to right now, or maybe it's 5 seconds. But I think every 20 seconds maybe it will check the CO2 levels and then report that here. And a really cool thing I just found out about yesterday, and let me move some things out of the way, is ToddBot just released a really neat serial monitor, little serial plotter called Serial Plotster. And I'll show it on my regular Thursday show and show you where to get it, or if Todd's around, he can drop that into the into the chat there. But this is a really nice chart that's showing me the CO2 values across the top and then temperature and humidity across the bottom. It's also got a console, so I'm connected over serial, USB serial to this, and I can see there, so my ppm for CO2 is about 689, 685. Let's go back to the chart here, and then what I'm going to do is I'm just going to breathe some CO2 into this little glass and kind of cover my sensor and watch the fireworks. So we just set that over the glass there. I'm not even sealing it, but I've just basically given it, oh my gosh, it's turned red, red alert, red alert. We're at 8,365 ppm. I'll go ahead and move the glass out of the way there and fan some fresher air from the rest of the workshop into there. You can see that dropping 2,000, 1,000. I think it'll turn amber here as it gets closer. Okay, now we're sub danger levels, so we go back to green. And then we'll eventually get back to the status quo that we were at. And this is quite simple to code. So let me go over to my code view. I'm going to hide the serial plotter there for a moment. And here is CircuitPython code that I have. I'm importing Adafruit STCC4. That's all you, even though we're going to get temperature and humidity, that's all you have to do is get that library. It has all of the temperature and humidity stuff built into it for the chip that's on board. Doing a little bit of I2C setup for my display and for this sensor. Create the sensor object, and I'm setting it into continuous measurement mode. And then all I do is I think I have it set to 5 seconds, yeah. Every 5 seconds, we go and check for CO2, variable equals sensor.co2. That's it, just ask for sensor.co2, gives it to you in parts per million. Temperature, it gives it to me sensor.temperature. Hum is sensor.relative humidity. So I grab those three things, and then I'm putting them into the serial monitor, as you saw before, as well as formatting it in a way that the serial plotter will show that as well. And then I just have a couple of little conditions here depending on breakpoint ranges, what color to turn the LCD into, and a little bit of error checking. So if I reset this, and let me bring up I'm going to bring back the serial plotster there. So I'm going to reset this. And you'll see here it goes into a little warm-up mode. So it needs about, I think it's 20 seconds is what I set it at, about 20 seconds to get settled before it starts spitting out readings. And there it goes. So I think that's back to about what we were at, a little bit higher. Maybe it's just me in here with the door closed breathing. I'm starting to fill up the air, although I do have HVAC turned on and I'm pulling in some fresh air. So that is, let me see, can we scroll back to so there's the peak there at over 8,000, and now we're back into this more comfortable 600, 700 range. That's great, fresh air. Shouldn't be getting sleepy from that. I might go get some caffeine anyway, but that's it's not CO2's fault. So these are great, and with the, let me go back to the product page there, you can see with the discount right now during the show, these are $13.75, which is a great price for this. As Lady Etta mentioned, we do have the more scientifically accurate SCD30, which is big and quite expensive. Let me see, do we have a link? Is this the link to it? Yeah. And the SCD40 also bigger, expensiver. So there you can see this one can be used in weirder situations than just expecting human breathable air. It's more of a true CO2 on its own sensor, and that one's $60. This one, we're out of stock of it right now. It's SCD40 is at $45, and Lamore mentioned the different differences between those three. Also, there's a great, let me go to Learn Guide. So if you scroll down in this, you'll see we've got a Learn Guide for the sensor with examples for CircuitPython and Arduino. Looks like maybe there will be a whippersnapper. I don't think that's active yet. That's why it's red there. But maybe there'll be a whippersnapper object for that as well. So this will give you all the details on this, as well as pinouts and setup. And then if you take a look, if you just search for this sensor in Learn, you'll also find that there's this great Ruiz Brothers project, the Star Trek Data Dispenser. And it includes this sensor in it and has some additional, if you check out the code for this, there's some neat stuff, including a CO2 calibration step and an offset. So you can take a look at that code and see some extra neat things you can do with it. But the sample code in the guide will get you started with something similar to what I have right here for just displaying what's the current ppm in the room here. Let's see how I can get it. If I set this on the desktop, I'm going to breathe in my glass again, cover that up, and it spikes up. Oh, that's actually, oh, there we go, 18,000. I'll bet the graph is going wild. Oh, I didn't reconnect to it. Let's reconnect. Okay, it's going to start off at a very high level here. Let's see. Give it a moment to send a value. There we go. So yeah, so we're starting off in the 22,000 range. I'll take the glass off of there. And it plummets down to a much more reasonable 12,000. That's not good. Again, I'll fan that off. 3,000. Okay, we're getting much more human breathable. 1,400. You can live in that. Hey, way better. Now we're sub 1,400 or whatever my breakpoint is. All right, so that is gonna do it, I think. Let's let me just check the chats and see if anyone's got any questions. Oh, hey, thanks, Tyeth. Tyeth over in the YouTube chat said that, yes, the Whippersnapper page is in progress. Let's check in with Discord. Oh, people like the cool retro display. I was actually looking for a TFT shield and couldn't find one, so I went old school, and actually I love it. Yeah, this is a nice way to do this type of display, is these little LCD matrix displays. They're great. So let's see. Todd put a link there, so if anyone wants to check out the Serial Plotster, you can download that for a release of that for a bunch of different platforms and get started with that. Oh, Tide says that support was added last week. Okay. Even better. Great. So the guide just needs to be updated. If you're curious about that, let me go over to Adafruit.io and if we, let's see, let's go to devices. All right, let's pick that feather there. I don't know which one that is, but let's try to add a sensor to it, and I'll just go STCC4. There it is. So you just add that and ask for your different values that you want to receive on your I/O page and your interval there. So yeah, maybe I'll do that on the Thursday show. Very cool. Thank you, Tyeth, for the update on that. Okay, and I think I have this on battery power as well. So I'm gonna unplug this. Oh, it decided to restart anyway. I think my batteries are dying. Okay, yeah, it'll just be a cool glowing thing with no numbers. That's all right. That right there is the product pick of the week this week. It is the STCC4 and SHT41 CO2 temperature and humidity breakout with Stemma QT. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you soon. Bye-bye.